Welcome back to section 11.3, Finding Complex Solutions of Quadratic Equations. Explain 1a. Solve the equation. State whether the solutions are real or non-real. We have 3x squared plus 9x minus 6 equals 0. So since 3, 9, and 6 are all divisible by 3, let's go ahead and divide the entire equation by 3. That way, our numbers will be a lot easier to work with. If you want to skip this step, that's completely fine too. We have 3 divided by 3, which is 1x squared, 9 divided by 3, which is 3x, and negative 6 divided by 3, which is negative 2. 0 divided by 3 is 0. Now that we have our equation, x squared plus 3x minus 2, let's check to see if we can solve this by factoring. And if factoring fails, then we'll have to use the quadratic formula. So I know a is 1, b is 3, and c is negative 2. Using the x method, we want a and c to go at the top, b is going to go at the bottom. When we multiply 1 and negative 2, that's going to give us negative 2, and 3 is going to go at the bottom. Okay, class, now we need to think of two numbers that'll multiply to negative 2, but will add up to 3. Well, the only factors of negative 2 are 1 and negative 2. 1 times negative 2 is negative 2, but 1 plus negative 2 is negative 1, not 3. So that's not going to work. We can also try negative 1 and 2. Negative 1 times 2 is negative 2, but negative 1 plus 2 is 1, not 3. Because there are no factors that will multiply to negative 2 and add up to 3, we know that this equation cannot be solved by factoring. So it's not factorable. That said, let's move on to the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's take our a, b, and c values and just plug them into our formula. X equals negative 3 plus or minus the square root of b squared minus 4, a is 1, c is negative 2, all over 2 times a, which is 1. Let's keep going. X equals negative 3 plus or minus the square root of 3 squared is 9, and negative 4 times 1 is negative 4. Negative 4 times negative 2 is positive 8, all over 2. Let's keep going. X equals negative 3 plus or minus the square root of 9 plus 8 is 17 over 2. And if we look at the number under the radical, notice how we have 17. 17 is a prime number, so we can't simplify radical 17, which means that our solutions are x equals negative 3 plus or minus the square root of 17 over 2. We also want to determine whether or not our solutions are real or non-real. Since we have no imaginary numbers, this means that our solutions are both real numbers. Let's move on to explain 1b. In this problem, we have x squared minus 2x plus 7 equals 0. Let's check to see if this expression is factorable. Let's identify a, b, and c. A is 1, b is negative 2, c is 7. Let's go straight into the x method. 1 times 7 is 7, negative 2 is going to go at the bottom. Okay, class, can you think of two numbers that will multiply to 7 but will add up to negative 2? Well, the factors of 7 are 1 times 7. 1 times 7 is 7, but if you add them, 1 plus 7 is 8, not negative 2. Another pair would be negative 1 and negative 7. Negative 1 times negative 7 is positive 7, but if you add those together, you end up with negative 8, not negative 2. That being said, x squared minus 2x plus 7 is not factorable. As a result, we are going to have to solve this equation by using the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's plug our values in. X equals negative b is negative 2, plus or minus the square root of negative 2 squared minus 4, a is 1, c is 7, all over 2 times a, which is 1. Let's continue. X equals a negative times a negative is a positive, positive 2, plus or minus the square root of. We have negative 2 squared, which is 4, and negative 4 times 1 is negative 4, times 7, that's negative 28, all over 2 times 1, which is 2. Let's keep simplifying. X equals 2 plus or minus the square root of 4 minus 28 is negative 24, all over 2. Now the 24 is composite, which means that we might be able to simplify the square root of negative 24. So I'm just going to make a note. Square root of negative 24. We have that negative under the radical. That automatically tells us that our solution is going to be imaginary. In other words, it's non-real, which also means that we are going to have an I. I know the factors of 24 are 4 and 6. And 4 is still factorable, so I know that the factors of 4 are 2 and 2. We're looking for the prime factors, that way we can write all the prime factors under the same radical. Going back to 6, the factors of 6 are 2 and 3. Now let's take all of our prime factors and, like I mentioned earlier, let's put them under the same radical. We have the negative times 2 times 2 times 2 times 3. Okay, class, we need to look for a pair of identical numbers. We have the negative, which turns into I. We also have 2 times 2, which is 4, and the square root of 4 is 2. Inside of our radical, we're left with 2 times 3, which is 6. Let's clean this up a bit. I times 2 is 2i, radical 6. So the square root of negative 24 is just 2i radical 6. If we go back to our problem, we have x equals 2 plus or minus. Remember, the square root of negative 24 is now 2i radical 6 over 2. So class, if you analyze your numbers, notice how our whole number is 2, 2, and 2 are all divisible by 2. So let's divide all of them by 2. X equals 2 divided by 2 is 1, plus or minus 2i divided by 2 is 1i, or just I, radical 6, and 2 divided by 2 is 1. And we know that any number divided by 1 is itself. So x equals 1 plus or minus I radical 6. So our solutions are x equals 1 plus or minus I radical 6. And because this is imaginary, that means that our solutions are also non-real. Now let's look at something a little more challenging. We have explain 3b. Solve the equation using the quadratic formula. So it wants us to use the quadratic formula, and when using the quadratic formula, the equation needs to be in standard form. In other words, it needs to equal 0. And unfortunately, our equation equals negative 1. Let's get rid of the negative 1 by adding 1 to both sides. Now we have 7x squared plus 2x plus 3 plus 1 is 4 equals 0. Now let's identify a, b, and c. A is 7, B is 2, C is 4. We know x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And from here on out, we're just plugging the numbers in and simplifying. So x equals negative 2 plus or minus the square root of b is 2 squared minus 4, a is 7, and c is 4, all over 2 times 7. Take it a step further. X equals negative 2 plus or minus the square root of 2 squared is 4. Negative 4 times 7 is negative 28. And negative 28 times 4 is negative 112. All over 2 times 7 is 14. Let's keep going, class. X equals negative 2 plus or minus the square root of 4 minus 112 is negative 108 all over 14. Now look at the square root of negative 108. Notice how it's even. You might be able to simplify that. So note, square root of negative 108. We know that the negative will turn into I. We'll deal with that later. 108 is divisible by 2, so let's go ahead and start off with 2. 2 is prime, that's done. 108 divided by 2 is 54. And the factors of 54 are 9 and 6. 6 is still factorable. The factors of 6 are 2 and 3. 2 and 3 are now prime. The factors of 9 are 3 and 3. And those are prime as well. So now let's take all of our prime factors and put them under the same radical. We have the square root of the negative 2 times 2 times 3 times 3 times 3. And then from here, class, we need to look for pairs. So the negative turns into I, as we know. We have a pair of identical numbers. 2 times 2 is 4, and the square root of 4 is 2. That's going to go outside. We also have another pair, a pair of 3's. 3 times 3 is 9, and the square root of 9 is 3. And inside our radical, we're left with just 3. Remember, the negative came out, and the negative turned into I. So if I make this a little neater, I have I times 2 times 3, which is also 6I radical 3. So class, the square root of negative 108 is just 6I radical 3. Let's go back to our problem. X equals negative 2 plus or minus square root of negative 108, and once again, that's 6I radical 3 over 14. So now let's look at our whole numbers. We have negative 2, 6I, and 14. All three numbers are divisible by 2. X equals negative 2 divided by 2 is negative 1. Plus or minus 6I divided by 2 is 3. 3I radical 3. And 14 divided by 2 is 7. So our solutions are negative 1 plus or minus 3I radical 3 over 7. This concludes part 1 of our video. If you liked the video, go ahead and hit the thumbs up button and don't forget to subscribe.